Hi, my name is Cliff Woolley. I'm a developer technology engineer with Nvidia. I'm here today to tell you about Nvidia's Cuda technology and help you to get an idea of what Cuda can do for you. So what is Cuda? Nvidia introduced Cuda in 2006. The term refers to two things. First, it refers to the massively parallel architecture of modern GPUs with hundreds of cores. Second, it refers to the Cuda parallel programming model used to program these GPUs. We need some way that we can program all these cores efficiently and easily. So now we have CPUs with several cores and we have GPUs with hundreds of cores, and we can use the two processors together as a heterogeneous system and get the best advantage out of each kind of processor. So what are the benefits of Cuda? First, Cuda gives us a way that we can efficiently process thousands of elements for a particular task in parallel. Second, it gives us a way that nearby tasks can communicate and collaborate efficiently. So in these heterogeneous systems, we have CPUs and GPUs which together can process many elements. Although on a CPU with several cores, each core is operating on perhaps one or two threads at any given moment. Whereas with GPUs, hundreds of cores, each core is working on tens or hundreds of threads simultaneously, juggling them. So overall, we have thousands of threads that the GPU is working with at any given time. So Cuda provides a scalable, intuitive way to express parallelism. We simply write a program for one data element and it gets automatically distributed across our hundreds of cores for thousands of threads. So is Cuda right for you? Well, what kinds of workloads does your application require? If you have a task-oriented application, for example, one that needs to update 5 records in a database, then GPU computing probably isn't the right choice. On the other hand, if you have a large amount of data that you need to process, for example, searching through a terabyte of data for a string, or a massively parallel molecular simulation, or engineering simulation, then GPU computing can be a very good fit. The hundreds of cores of the GPU give us a high throughput way to process our computing job. And most of the interesting compute tasks these days are throughput problems. So how does it work? Well, the days of free scaling are over. You have to go parallel, so Cuda gives you a way that you can express parallelism in a way that will scale with future architectures in languages you already know, like C, C++, Fortran, and so on. It will allow you to take advantage of libraries like our BLAS and FFT libraries and others to get best-in-class GPU performance. And it will give you an ecosystem of developer tools and solutions that allow you to fine-tune your own code to get best performance out of the GPU. So let's take a look at an example that'll show how it is that Cuda makes it easy for us to express all this parallelism we've been talking about. Consider a case where we have 3 vectors, A, B, and C. And we simply want to add these vectors, A and B, and store the result into C. Well, in C, normally, in the sequential case, this would simply look like a loop that says for I equals 0 on to n minus 1, where n is the length of the vector. Then one element at a time, I add the 0th element to the 0th element, and then the first, and then the second, and so on, down the chain, one at a time in series. So in Cuda, instead what we consider is each of these individual additions is a thread, and a thread operates from the perspective of one data element. So instead of this being a loop, we write it like a function to which we pass these 3 vectors. And each thread has an index. So now each thread is operating on exactly one element, and we simply need n threads. So we add a little bit of syntax to our function call, which otherwise looks just the same as an ordinary function call. This extra little bit of syntax, to simplify a little bit, basically just tells us how many threads we need. So then our function call, instead of executing exactly once per call, executes n times as n separate threads, 1 thread per data element. This gives us an easy way to express this parallelism, and n can become very large, thousands, perhaps even millions, allowing us to scale up to even greater levels of parallelism. In conclusion, Cuda is all about high performance. If you have a lot of data to process, If you have a compute-intensive problem, Cuda's for you. Here's how you can get started. First, go to Cuda Zone at nvidia.com/CudaZone. Then you can download the Cuda Toolkit at nvidia.com/getcuda. And then you can watch the Cuda webinars, nvidia.com/webinars. Thanks for watching, and I look forward to seeing the great things you do with Cuda.